to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students of Senior 3 Chemistry class. I'm very excited to be with you once again in this 30-minute session. We are on unit number 9. It's about structure, properties of alkenes and alcohols. So that is the unit 9. And our lesson number 1 will emphasize on the structure. We'll talk about the preparation methods. Then we go to nomenclature, that is the system of the naming of these compounds. And then we look at the uses and the properties. So the properties here of the alkenes, we are not talking about the properties of alkenes and alcohols, because in this unit we have the two parts. There are two groups of compounds that we are supposed to look at, the alcohols and the alkenes, but we'll first look at the alkenes. So when we're talking about the structure, the preparation, the nomenclature, uses and properties, we are referring to those of the alkenes. And later on, we'll also look at the alcohols and look at all the same things with the alcohols. So my dear students of Senior 3, I urge you to pick your pen and a notebook, put down some information, necessary information, and we go along together. Thank you. So here we go. So we'll start with this is the general information. What do we need to know about these alkenes? So these are a homologous series of compounds, a family of compounds with a double bond. That is very, very important. With a double bond. Double bond. So that is very, very important to remember, that they are compounds with a double bond. Remember, the alkenes have got only a single bond. And these compounds are represented by the general structure, the general formula of these compounds is written as CnH2n. These are some of the things you need to remember about the compounds. The general structure, the general formula, and you should remember that these compounds, because of the double bond, the presence of the double bond, they are also generally called unsaturated compounds. Unsaturated compounds. Unsaturated compounds. So unsaturated compounds meaning what? They have less number of hydrogen atoms. Less number of hydrogen atoms. Less number of hydrogen atoms compared to those of the alkenes. You remember the alkenes, what we mentioned? We said they are saturated. So these are unsaturated. So what you should also remember, very important, is that they also belong to the family of those compounds that are referred to as hydrocarbons. They are referred to as hydrocarbons. What do we mean by the hydrocarbon? I hope, dear students, you still remember this term. Thank you. So the hydrocarbons are the compounds of carbon and hydrogen only. So that is the general information that you should always remember about the alkenes. So we move on to the nomenclature, naming these compounds. How do we name the compounds? Remember, when we go to the alkenes, in the Senior 2, we said alkenes, in the naming of these compounds, they end with N. That is the suffix N. They have that ending N. Those are the alkenes. But for the alkenes, they have the ending in. So this is the ending in, the suffix in. Alkenes. So that is where the name is derived from. That is where the names are derived from. These alkenes are named, remember, because we said these alkenes must have the double bond. So the first member of these compounds do not have, the first member of these compounds do not have, rather the first member of these compounds do not have one carbon atom, like in the alkanes. In the alkanes, we have methane. So they are also derived from alkane. So in the alkanes would have methane ending with "in." This one does not exist. Why? Because we don't have, we said these compounds have got a double bond between the carbon atoms, and therefore that methane wouldn't be having, it has only one carbon atom. And where would the double bond exist? So because of the lack, because of the presence of the double bond, the first member is ethene. So we have ethene as the first member. Ethene. So ethene, that means when the number of carbons are 2, so we have C2H. When you add this one, this would be C4. And the structure would be written in this form with the hydrogen atoms. This is a hydrogen atom, this is another hydrogen atom, and this is another hydrogen atom. So that is the first member. You may have the second member as propene. When you have propene, that means the 3 carbon atoms, so that will be, the molecular formula will be C3H. That is, how many are they? 2 times 3, that is 6. So what will be the structure? When you want to write the structure, you need to write the carbon atoms. These are carbon atoms. You put the double bond anywhere you want. Between the, as long as the double bond is between the carbon atoms. So we can put the double bond over here. And then we put the hydrogen atoms. Make sure, what is very important is that the carbon atom cannot be surrounded by more than 4 bonds. So you'll have 1 hydrogen here, you have hydrogen here, you have another hydrogen, you have another hydrogen, you have another hydrogen. Can we put another hydrogen here? No, it is not possible because we'll have 1, 2, 3, 4. So this one is satisfied. So that means we'll have the hydrogen atom here and another hydrogen. So this one doesn't have. So we can have another compound. We can have butene ending that is very important. So that is C4. You remember you need to use this one. The hydrogens are how many? When the carbon atoms are 4, so these ones will be 8. So that means you have put the carbon atoms, the 4 carbon atoms here. 1, 2, 3, 4. Put the double bond anywhere you want. I can put the double bond here. If I put the double bond here, then that means I can have as well, I put the hydrogen atoms. This is the hydrogen, this is the hydrogen. How many hydrogens will be needed here? 1, 2, 3. So we'll need another bond here to make 4. Remember, carbon has to be surrounded by the 4 bonds. So you'll have 1 hydrogen here, another one here, another one here, and another one here. Now, what if I change the position of the double bond? So this one will change. If I have C like this, how many are these? 1, 2, 3, 4. So we need, if I change the position of the double bond, I put it here, what will happen? So if I add, I've changed from this now to this. The number of carbon atoms remain the same. So I put the hydrogen atoms. This is the hydrogen. How many are needed here? 1, 2, 3, 4. So I need only 1. How many are here? 1, 2, 3. So I put another one here. So I will put 1, another one here, another one here. So remember, that is very important. You need to indicate this. So when you look at these two compounds, what is the difference? The difference is on the position of the double bond. So this one, the double bond is on carbon number 1. So you'll have, that's why we call it butene 1-in. It is but 1-in. Whereas here, either starting from this side or that side, the position of the double bond is 2. So this is but 2-in. So what is the common name that is given to these compounds? We talked about this one when we were talking about the alkanes. So what is the name, the special name given to these compounds? Thank you so much. These are called isomers. These are called isomers. So we can move on from the nomenclature. We look at the manufacture and sources. So these alkenes are manufactured, or they are obtained from alkanes. Long-chain alkanes through fractional distillation. Long-chain alkanes through fractional distillation. So they are broken down. Long-chain alkanes are broken down into shorter ones. And those among the shorter ones include the shorter alkanes, the alkanes with less number of carbon atoms, including the alkene, and sometimes the hydrogen atom. The hydrogen gas is also released. So this is one of the examples. So the breaking down, there are different methods. We call it cracking. That is one of the methods of preparing alkenes. We call it cracking. Cracking has got, so we have different forms of cracking. We have thermal cracking, we have catalytic cracking, and then we have steam cracking. So those are different forms of how the compound can be broken down. So let's look at the screen over there, and then we see what is happening. When you look at the screen, this is the can. This is an alkane with 10 carbon atoms. So through either heating or catalytic or thermal, it is broken down into octane. This has less number of hydrogen atoms, a less number of carbon atoms, I beg your pardon, plus the ethene, which is also produced. So a long chain, an alkane, broken down to produce an alkane and an alkene, but alkane with a shorter carbon, the shorter number or less number of carbon atoms. These are very important. So another method is dehydration of alcohols using aluminum oxide. They are hydrated. Look at the screen. You have the glass wool soaked with ethanol, and then aluminum oxide as a catalyst heated at around 350 degrees Celsius, it will produce ethane. That is one other method, which is dehydration by aluminum oxide as a catalyst, and heat. The heat must be 350 degrees Celsius. So the ethene is produced. So that is another method. And another method is dehydration of alcohol. So that is part A. So there are two parts under dehydration. You have dehydration by aluminum oxide. So when you have ethanol, C2H5OH, this is dehydrated 350 degrees Celsius in presence of aluminum oxide as a catalyst. This will produce C2H4 plus water. Dehydration means removing water. So the same reaction, alcohol can be dehydrated using the concentrated sulfuric acid at 0 degrees Celsius, in presence of concentrated sulfuric acid. So it will produce ethyl hydrogen sulfate, which is indicated C2H5 H5 as indicated on the board, HOCO3H, then plus water. So this one can also be dehydrated to form ethene. So when this one breaks down, it is very unstable. So it breaks down to produce ethene, regenerating the concentrated sulfuric acid. So concentrated sulfuric, so that dehydration can also be done at different temperatures. So we have said this one breaks down to regenerate. So you have C2H5, CO3H. This is, so this one breaks down into, we have it on the screen. So this is what we have, SO3. So I think we don't have this. So this one now breaks down because we said it is unstable to form ethene plus concentrated sulfuric acid. So that is what is mentioned. So the reaction, this reaction can also take place in the presence of concentrated sulfuric acid, but this time it is 180 degrees. So this one will produce direct ethene, C2H4 plus water. So this is also another dehydration reaction as indicated. That is the reaction that is indicated. So that is another method. So we can look at the chemical properties of the alkenes. They are reactive because of the presence of the double bonds. They are very reactive compared to alkenes. So they, first of all, like alkenes, they undergo complete combustion. For example, if you have ethene, you can mention about the combustion reaction. Under combustion, you have ethene, C2H4 plus oxygen. Under complete combustion, you give the same products, carbon dioxide and water, plus heat, but less heat compared to the alkenes. That's why alkenes are not used as fuels, because they will produce less heat compared to the alkenes. Then another general reaction that we can talk about is addition reactions. Addition reactions. So under addition reactions, there are several number of reactions that we can look at. We'll have reaction with halogens. Just look at the screen over there. This is ethene plus bromine, then it gives 1,2-dibromoethane. So this is circulated. Bromine, this bromine, one bromine adds to this carbon atom, another one adds to this as the double bond breaks down. The same reaction can also take place with chlorine. If you have the chlorine, you'll have, say, this is H, this is H here plus chlorine. So you'll have chlorine now, the double bond breaks down. So you'll have one hydrogen, this is chlorine. You'll have chlorine there, and like this. This is 1,2-dichloroethane. So it is the same reaction. This reaction is very important because it is used as a chemical test. Chemical test for unsaturation. Chemical test for unsaturation. How? Bromine is reddish brown. Bromine is reddish brown. So what happens when you pass an alkene to this reddish brown color? It fades out or disappears. So that is the test that is very important. It can be chlorine or it can be bromine. Hydrogenation is also another reaction under addition reaction. In the presence of a catalyst, 150 degrees, nickel, palladium, platinum, or those can be used as a catalyst. So the ethene is converted into ethane. This reaction, I want to remind you, dear students, is a very important reaction because this is the reaction that is used in conversion of oils into fats. Oils are unsaturated. They contain a double bond. When they pass hydrogen, then it converts, it becomes saturated and then solidifies. So in industry, when you have oils are liquids at room temperature, whereas fats are solids at room temperature. I can give you margarine, or margarine, the way you call it. It is a solid, but it is saturated. But how do we convert it into other compounds? So it has to be changed under that reaction. So you'll have unsaturated, the oils which are unsaturated, then converted into saturated through that reaction. So it is a very important reaction in industry. Hydration of alkenes. This is one of the reactions also which is very important. Under addition, it shows how ethene reacts with water in the presence of phosphoric acid. It forms the alcohols. That is a very important reaction. Reaction with hydrogen halides, still, it is addition. The one hydrogen adds here, and the chlorine adds here. So it forms chloroethane. It is under addition reaction. Then polymerization, that is a very important also uses of the alkenes in polymerization, where the alkene molecules join up together to form a bigger molecule, which is polyethene. So you have ethene molecules, very many ethene molecules. Now, ethene molecules combining together, so it could be any number of molecules, could be thousands of those molecules to form polyethene, where we get the polyethene bags. So the polyethene bags are got from these ethene molecules. In the industry, when you see these polyethene bags used for packaging, mainly, and other uses, you can also look at other uses. Polyethene is made from ethene, which is an alkene. A very important use of these compounds. Now I will just leave some homework, but before I leave, I just read the homework. I just want to take you through of what we did from the beginning, or what we were supposed to look at from the beginning. We looked at the general structure of these compounds. These are double bonds. We looked at the general formula of these compounds. You remember the general formula for alkanes as well. So we said they are also unsaturated because they contain the less number of hydrogen atoms. When you compare ethene and ethane, the number of hydrogen atoms are not the same. Ethane, which is an alkane, has 6 hydrogen atoms, whereas ethene has 4 hydrogen atoms. And we said they also belong to a bigger group of compounds called hydrocarbons, where we have alkanes, alkenes, and alkynes. Unfortunately, we will not look at the alkynes, but you'll meet them at a later stage in senior 5. Then we look at the naming. When we looked at the naming, we said their naming, or their names, end with "in," the suffix "in." That's why they are called alkenes, because they end with "in." And we looked at some of the examples. Under the examples that we looked at also the isomerism, the existence of compounds with the same molecular formula, but different structures. Look at but 1 in, but 2 in, different positions. So these are structural. They are positional isomers. Positional isomers because they differ on the position of the double bond. Then we looked at the methods of producing these alkenes. The first one was cracking. We looked at the cracking. Cracking is breaking down of the molecules, large molecules, into smaller molecules with less number of hydrogen, less number of carbon atoms, including the alkenes. And then we talked about dehydration, whereby we said under dehydration, we can have different substances. Aluminium oxide as a catalyst, concentrated sulfuric acid as also a catalyst. Those are substances that can also be used. Then we looked at some of the chemical reactions, the chemical behavior. Under the combustion, we said they also undergo combustion. However, if you remember, we said they are not used as fuels. Why? Because they produce less heat compared to the alkanes. And that is why they are not used as fuels like alkanes. The fuels like alkanes. Then we looked at the addition reactions. Under addition reactions, we looked at the reaction with halogens. That is the reaction with group 7 elements. Can be chlorine or chlorine. In addition reactions, we said the atoms add between the carbon atoms containing the double bond to become saturated. And the most important reaction that we looked at under, even other reactions are also important, but something that you should also remember is that this reaction of chlorine and bromine are used as chemical tests for unsaturated. If it is bromine, bromine is reddish brown, so it will change into colorless if a thin molecules are passed. Then we looked at another addition reaction, polymerization, whereby a thin molecules combine together to form a bigger molecule, which is polyethylene. Addition, that means adding together. That is what we looked at, my dear students. This is the homework. I hope you have already taken the homework. Distinguish the chemical tests that can be used to describe the chemical test that can be used to distinguish between a thin and a thin. We have just mentioned. Include the reactions and observations. That is very important. Write equations for the reactions that occur when ethanol reacts with concentrated sulfuric acid. You remember, it is still on the board as well. Which other test can be used to distinguish alkenes from alkanes, apart from the tests you have? So you have to go ahead and do some kind of research, because we have not mentioned that. Thank you so much, dear students. I hope to see you in the next session. Have a good day, and bye-bye.